Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Tani. I would like to explain the manuscript of Analysis of Bacterial Community from the Research Fair of Salut Alim Askalamikum in the Central Java using Next Generation Sequencing NGS approach. With author by Ratna Rosastuti, Tani, Sumani, and Siakati. Introduction. Brebes is the largest salad center in Indonesia. This area contributes 80.5% of national production or 57% of production in Central Java. In the cultivation of salad encourages many problems, and one of them is the type of plant destruction organism. To overcome the problem of damage caused by pests, farmers generally use chemical pesticides. In any case, use of insecticides to control agricultural crop pests will affect the quality of soil, water, and crop. Soil biological diversity is very important in the balance of soil ecosystem. Is also an indicator of soil health and can affect the condition of plant growing on it. In the management of natural resources, biodiversity information is needed to maintain the sustainability of species, use, explore biological potential, and monitor species and their ecology, make policies, and for the development of biotechnology innovation. The aim of this study one is to isolate bacteria from the reservoir of salud. Two, to obtain a consortium of bacteria from the field capable of degrading chlorpyrifos from toxic compounds to non-toxic compounds. Material method, self-sampling. Self-sampling was created in May 2021 in Sheffield, one study and Songom Brebes frequency. Isolation and morphological identification of the bacterial consortium. The sample inoculum was inoculated by the spread plate method in the soil extract medium. During the isolation process, the growth of microorganisms was observed by the total bite count method. Molecular identification. PCR amplification of the target region was performed using specific primer linked by barcode. PCR product of suitable size were selected by 2 persons across gel electrophoresis. The same amount of PCR product from each sample was collected, then fixed at the end, a tail and then tied and illuminate adapter. The libraries were sequenced on Illumina paired and platform to produce 2,150 base pair, red and red tip. The final pair reading is done based on its unique barcode and then transcoded by cutting the barcode and main sequence. Read and read were performed using flash and analytical tools that is accurate in paired read when there are multiple reads overlapping with read resulting from upside in and of DNA with the same fragment, and the splicing sequence is called raw tag. Raw tag quality sequencing was carried under special screening conditions to obtain high quality clean tag according to claims. They were compared with the reference-based silver database using the UKIMA algorithm to detect camera sequence to obtain phylogenetic relation of all ODU representative sequence. Most people can quickly compare multiple sequence normalization of operation taxonomical unit ODU is performed by using the standard sequence number that correspond to sample with the small order. Result and discussion characteristics of solid reservoir soil. Composite soil analysis show that the solid reservoir in several observation areas has a pH tend to be acidic. The organic matter content in KB2 solid field is low and KB4 mixed forest is high, and the N content is in KB2 was very low and KB4 very low. The result of the analysis of the available input are for KB2 medium and KB4 very low. Furthermore, the result of KF available at the location of KB2 were high class and KB4 were medium. Further community analysis using non-cultural method with NGS. Based on the result of band analysis, the overlapping pattern of ODU group among different samples is obtained in figure 1. For sample KB2 and KB4, each accommodate 57 ODU and 24 ODU with combined set between the two of 73 ODU. This result indicates the soil bacterial community in KB2 is very similar to the soil bacterial community in KB4. This is presumably because most of the soil bacteria in KB2 come from the same soil environment as KB4. Taxapilum. In general, the relative abundance of soil bacterial phyla in KB2 and KB4 has a significant difference, except for the Proteobacteria phylum. The most dominating phyla of KB2 are phylum Protobacteria and Actinobacteria. So in KB4, it is dominated by phylum Microbiota and Cyanobacteria. This phylum is not found in KB3. Genus abundant in soil, solid KB2 and forest KB4. The abundance of genera found in solid field KB2 and forest KB4 consists of 86 genera grouped into 52 families, 20 classes, and from 9 phyla. The 9 group of phyla depicted by the cladogram in figure 2 include the phyla Proteobacteria, Actinobacteria, Firmicutes, Fusobacteriota, Disulfa, Bacteriota, Bacteriodota, Microbiota, Cyanobacteria, and others. The predominant phyla group for solid soil KB2 in this study were Proteobacteria, Actinobacteria, and Firmicutes. The most dominating phyla is Proteobacteria. The classes in the Proteobacteria detected in the study were Delta, Alpha, Beta, and Gamma Proteobacteria. This sequence is similar to that of the more typical soil community structure with alpha, delta, beta, and then gamma proteobacteria sequence. Conclusion: the soil bacterial communities in KB2 were 7 phyla, KB4 were a phyla, in order of the largest to small, relative abundance of KB2 including Proteobacteria 0.970% and Actinobacteria 0.015%, Firmicutes 0.014%, Fusobacteria 0.001%, Desulfobacteriota 0.0003%, Bacteriodota 0.0001%, and others 0.011%. In KB4, there are 8 phyla, namely Elusi microbiota 6.385%, Cyanobacteria 3.192%, Proteobacteria 0.9861%, Actinobacteriota 0.0041%, Firmicutes 0.0089%, Desulfobacteriota 0.0001%, Bacteriodota 0.0002%, and others 0.0003%.